examples on simplification, expansion, factorization, just to show you that these are steps, that are normal, and they are part of equations when we're solving equations. But note the word simplify in the question. When we say simplify, you will see that there is no equal to. We sometimes students confuse solving an equation to simplifying an expression. You simplify an expression, you solve an equation. An expression is something like this, there is no equal to any side. An equation will always end with equal to. So when you have a following like this, you have simplified means make this to look neater, so to speak. So the first problem is to remove the bracket, but there's a negative sign outside the bracket, so remember that minus times plus or whatever, same signs multiply or divide to give plus, and different signs again multiply or divide to give minus. That's all you need to remember. And in collecting like terms, this is for multiplication and division. In collecting like terms, take negative as something that you owe and you have to pay. Positive as something that you own. That makes it easy for you to collect terms. So here, we open this bracket. And you have 2a minus 6 times plus 1 will give you minus 6. Minus 6 times minus 2a. Minus times minus, they are same signs. So minus and minus, you get plus. So same signs multiply. And you actually multiply because having 6 outside the bracket means 6 times every term in the bracket. So minus 6 times minus 2a will give you plus. Note, plus 12a. The next thing is to rearrange because our 2a is more or less scattered, so we rearrange. And so you have 2a plus 12a minus 6. And now we collect like terms. You collect like terms. So 2a plus 12 will give us what? 14a minus 6. Now, you will agree with me that this expression is simpler than the first one, which is all you're supposed to do, simplify. B. In B, we have 2 brackets instead of 1. So first step, we remove brackets. We remove bracket and we have x times x, which will give you x raised to power 2. And x times minus 3 will give us minus 3x. Then minus 5 times x will give us minus 5x. Then minus 5 times minus 3, minus times minus will give us plus. Please, it is very important to take note of your signs. Plus 15 minus times minus, same signs multiply to give plus. So we now collect like terms. The arrangement is okay. Now the only 2 like terms we have here are the minus 3x and minus 5x. So the question is, are they like terms only in terms of letters or also in terms of sign? They are like terms both in terms of letters xx and both in terms of signs. They are both negative. So if I'm owing 3x somewhere, I'm owing 5x in another place. All together, I'm owing 8 things. So you have your x squared minus 8x plus 15. And that is your answer. This is a quadratic expression which we'll go into next. Over 5, 4a over 5 minus 2a over 5. Now, this is just like any fraction you can have. If you have 2 over 5 plus 3 over plus 2 over 5, you just add 2 plus 2 over 5. So what you do normally for fraction, you do it here. Take the LCM to be what? 5. 5 in 5, 1 times 4a. So you just get your 4a minus 5 in 5, 1 times 2a minus 2a. And the answer simply is 4a minus 2a, which is 2a over 5. It's the same thing you do when you have fractions. This could be done with 4 over 5 minus 2 over 5, and that's what you normally do. Here, the LCM is a bit different because we have k and 3k. So what's the LCM of k and 3k? When you do this in GS1, I'm sure you must have missed out how to get to LCM. Now you have to go back and revise. When you are given terms and you are supposed to find the LCM, you look at the different letters you have. All letters must be represented, all numbers, when you look at the numbers, you make sure all factors are picked. And when there's any extra factor that is not common, you still pick them. So we have here the LCM of k and 3k is just 3k. Because 1 and 3, LCM is 3. K and k, LCM is k. So your LCM is 3k. But k in 3k will give you 3. So you are left with just 3 times 4, which will give you 12. Plus 3k in 3k is 1. 1 times 5 will give you 5. So our answer becomes 12 plus 5, 17 over 3k. Here we have the same situation, except that we have an expression as our numerator. So we want to brackets to help us. We need brackets to tie up what is on top of 4. The LCM once again is very straightforward. LCM is what? 4 and 4. So the LCM is just 4. 4 and 4, 1. So you have 1 to that bracket. So you have 1 times, you don't have to write the 6a plus 1 plus, again 4 and 4, 1. So 1 times that, you get your a minus 5. That means when you have an expression on top of that, the first step to take is to open brackets. Open bracket, because that is the only way you can see clearly what is your numerator. And the next thing is to now remove the bracket. When you remove the bracket, you have 6a plus 1 plus a minus 5 over 4, which is equal to, when you rearrange now, rearrange 6a plus a, and then plus 1 and minus 5 all over 4. And then you collect like terms. When you collect like terms, it becomes 6a plus a, 7a plus 1 minus 5. Are these like terms? No. This is negative, this is positive. So you have only one thing to pay back, and you are owing 5. So you still be owing 4. Plus 1 minus 5 will give you minus 4 all over 4. And that, I'm sure you'll agree, is simpler than what you have here. So when they say simplify, it means reduce this to a very, very simpler form. It is not an equation, and you are not expected to solve for the letter. F, it's almost the same thing as the last one, except that what you have as denominator here, it's not like the others. So the LCM of 2CD and 3DE, 2 and 3, LCM of 2 and 3 is 6. Now C, there's no C there, so you still pick your C. DD, although you have DD, they just pick it once, you don't have to multiply. Then there's E here, although there's no E there, you still pick the E. The rule in picking your factors for LCM once again is pick all factors present. And where you have more than one, that is, if they have the powers, you compare the powers, pick the one with the highest power. So this is the LCM. And 2CD in this, 2 in 6 will give you 3, C will cancel C, D will cancel D. So you'll be left with E and then 3. So you have 3E. 5 times 3E will give you, well, let's just write 3E times 5. Once again, 2CD in 6CDE. 2 in 3 will give you, in 6 will give you 3. C will cancel C, D will cancel D. You are left with just E. So this 3E times the numerator, the normal thing we do, this is that times that. Plus 3 in 6 is 2. D will cancel D, E will cancel E, you are left with C. So you get 2C times 4. And then you now have 3E times 5, that is 15E, and 2C times 4, that's 8C, all over 6CDE. And that is the simplest you can go. There is usually a terrible mistake that students make. In looking at this, they may say, oh, 15 and 6, 3 here 2, 3 here 5. That is not possible. Never cancel when you have a whole expression. You cannot cancel them in parts. The best you can do is probably the next thing we talk about, you factorize. And then you cannot have products over a number and then you can cancel. So don't attempt to do that, which is the mistakes I've discovered most students make.